Hello friends! Today we're going to be talking about scientific notation. Please put this title on the top of a fresh clean page for your notes. Okay, at this time please pause your video and write down these steps. When you're done writing them down, we'll be going through them step by step with some sample problems. Alright, let's get started with example 1. Please write the number 560 billion in your notebook. That there's no decimal in the number. If there is not a decimal in the number 560 billion, this one at the end of the number. So I rewrote the number and I am going to put a decimal point right there at the end of the number. Step number 2 said move the decimal to the left until the number becomes a number greater than 1 but less than 0. So I'm going to be moving the decimal all the way to here. Okay, this number now becomes 5.6. The number 5.6 is larger than 1, but it's smaller than 10. And that's how I know that I've got my decimal point in the right spot. Step number 3 said truncate the zeros. Most of us probably don't use that term a lot and probably don't know what that means, but that means that those zeros after the number 6, since they follow a decimal, are no longer necessary. 5.6000000, etc. is the same as the number 5.6. So when we drop those zeros at the end of our number, that's called truncating the zeros. Okay, step number 4 said write times 10 after the remaining decimal. So I'm going to write times 10 after my 5.6. Okay, step number 5 is going to be write the exponent that's after the power of 10 number. Okay, so in order for us to do that, we need to count how many places we had to move our decimal to get it to be in between the 5 and the 6. So if I start here and count how many places I moved it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that tells us that our exponent on the 10 will be the 11th power. So the number 560 billion, written in scientific notation, is 5.6 times 10 to the 11th power. For example 2, we're going to be writing a small number. Okay, this number is very small, less than 1. We can write this in scientific notation following the same steps, but we're going to make a very minor adjustment. So let's take a look at that, how that looks. All right, this decimal number is 8 ten-thousandths. We know that that's a number that's less than 1. In our steps, it said if there's no decimal in the number, place one at the end. Well, we do have a decimal in this number. Step number 2 said move the decimal to the left until the number becomes a number greater than 1 but less than 10. In this case, in order for us to create that number that's greater than 1 but less than 10, we are going to have to move our decimal to the right. And it will end up right here. Now that number is 8 or 8.0. Either way, that's the same exact thing. Step number 3 is truncate the zeros. In this case, truncating the zeros means we're going to cross off or eliminate these zeros that are before our decimal. Step number 4 is still write times 10 after the remaining decimal number. And step number 5 is going to be to write the exponent. Okay, now in this case, we are still going to look at how many places we had to move our decimal. So we started here and we moved 1, 2, 3, 4. But since we moved our decimal to the right, we are now going to have a negative exponent. Okay, in some earlier lessons we learned that numbers that have negative exponents are less than 1. That's going to be important to remember. The number we started with was a number less than 1, and that is why we need a negative exponent on our scientific notation number. So our answer to the problem writing 8 10,000ths in scientific notation is 8 or 8.0 times 10 to the negative fourth power. Done. At this time, please pause your video and write down the steps for converting numbers in scientific notation back into standard form. We'll be going through these steps together with some sample problems, so if you're not sure what they mean while you're writing them, don't worry. Okay, please write down example 3. We're going to take the number 7.659 times 10 to the second power, which is a number written in scientific notation, and we're going to convert it back to standard form. Okay, our first step told us that we're going to be moving our decimal point, the number in our exponent. Okay, since we have a positive 2, we're going to be moving our decimal here 2 places to the right. Since it's positive, we move to the right, and we will rewrite our number without these little loop-de-loops as 765.9. There is our number written in standard form. It's no longer in scientific notation. All right, let's try that again. This time we're going to write 9 times 10 to the fourth power in standard form. Okay, the number 9 does not have a decimal, so we will put one at the end of the number. And then our exponent of positive 4 tells us we're going to need to move that decimal point 4 places to the right. Okay, now in this case, we don't have any numbers there. So we're going to fill in those loop-de-loops, as I like to call them, with zeros, and our new decimal will be after that 0. Then we rewrite our answer in standard form as 90,000. There's our final answer. All right, example 5, we're going to write the number 3 times 10 to the negative 1 into standard form. This scientific notation number, we know it's going to turn out to be a number that's less than 1 because our power of 10 number has a negative exponent. Okay, the change we're going to make here is that we'll take our number 3, we can always add that decimal, and we're going to have to move our decimal 1 place to the left. Whenever we have a negative exponent, we'll have to move our decimal 1 place to the left, and here's where it will end up. And then we'll rewrite our answer. 0.3 is the standard form. All right, ladies and gentlemen, example 6 is our last example. Please write this guy in your notes. We've got 2.8 times 10 to the negative 5 power. A negative exponent means we're going to have to move our decimal point to the left, in this case 5 places. So I'm going to start here and move 1, 2, 3, 4, 5. This is where my decimal is going to end up. These little loop-de-loops are going to get filled in with a 0 placeholder. I always add a 0 in front of that decimal, so I know that there's no whole number and that this is a number less than 1. And I will rewrite my answer. Remember that we knew from the beginning with our negative exponent here that we should end up with a number less than 1, and we did. All right, I think you're ready to try it on your own. Good luck, guys.